Hello everyone, this is Vijay and welcome to my YouTube channel. The topic that we are going to look today is tricks on cyclic group. These tricks are useful for the students who are preparing for CPGET, HCU and all other university entrance examination. So guys, before going to the today's session, subscribe to my YouTube channel and follow me in Telegram for more updates. Now let's start the today's session. Now see here what is given: cyclic group. Cyclic group is given. Here we have two types of cyclic group. First one is finite, second one is infinite cyclic group. Infinite cyclic group means that group contains infinite number of elements. Finite cyclic group means that group contains finite number of elements. Now let's see the infinite cyclic group. Infinite cyclic group, here remember one point: for every infinite cyclic group, there exist only two generators. For every infinite cyclic group, there exist only two generators. Now let's see here, if A is a generator of the infinite cyclic group, then A inverse is also generator of the infinite cyclic group. If A is a generator, then A inverse is the inverse element of A. What is A inverse? A inverse is the inverse element of A. If A is a generator, then the inverse of A is also generator of the cyclic group. Now let's see the example. Set of integers, it is an infinite cyclic group. So what are the elements in infinite cyclic group? 0, plus or minus 1, plus or minus 2, so on up to infinite. Okay. Here 1 is the generator. Here 1 is the generator of the cyclic group Z. Here 1 is the generator of the infinite cyclic group Z. Then minus 1. What is the inverse of 1? Inverse of 1 is minus 1. Then minus 1 is also generator of the infinite cyclic group Z. For example, if 2 is the generator, of the infinite cyclic group, then what is the inverse of 2 with respect to the addition modulo? Minus 2. Minus 2 is also generator of the infinite cyclic group. For example, if 3 is a generator of the infinite cyclic group with respect to the multiplication. For example, if 3 is a generator of the infinite cyclic group with respect to the multiplication, what is the multiplicative inverse of 3? 3 inverse. 3 inverse is also generator of the infinite cyclic group. For Z, 1 and minus 1, these two are the generators. I am saying examples here. If 2 is a generator of the infinite cyclic group with respect to the addition, then minus 2 is also generator of the infinite cyclic group. If 3 is the generator, of the infinite cyclic group, then 3 inverse is also generator of the infinite cyclic group with respect to the multiplication. Okay. Now see the second one, finite cyclic group. Finite cyclic group means that group contains finite number of elements. What is the order of the group? Order of the group is some finite value, that is n. Here if addition modulo is given, addition modulo n, then the number of generators of the finite cyclic group. Here we have one formula to find the number of generators of the finite cyclic group is pi of n. By using this formula, we find the number of generators of the cyclic group. But actually what we required? We required which one is generator of the finite cyclic group. By using this formula, we find the generator of the finite cyclic group. Let's see here. If GCD of element and order of the group is equals to 1, then that element is a generator of the cyclic group except identity element. For example, if order of group is equals to 9 and 2 is the element of the group, what we find GCD? If GCD of 2 comma 9 is equals to 1, what is the GCD? If GCD of 2 comma 9 equals to 1, then 2 is the generator of the finite cyclic group G. Then 2 is a generator of the finite cyclic group G with respect to the addition modulo n. If multiplication modulo is given, then the formula to find the generator is if order of element equals to order of group. If order of element equals to order of group, then that element is the generator of the finite cyclic group. For example, if order of group is equals to 4, if order of the group is 4, 2 is the element of G. Then the order of an element 2 is also equals to 4. What we observe here, order of an element and order of the group, these two are equal. these two are equal. Then 2 is a generator of the finite cyclic group with respect to the multiplication modulo. Now let's see some of the example problems based on finite cyclic group and infinite cyclic group. Now let's see the example number 1. What is given? G equals to a to the power of 1, a to the power of 2, so on a to the power of 8, which is equals to identity element E, and binary operation is placed. In group G contains 8 elements, so the order of the group is equals to 8. Here how many elements are in group G? Here 8 elements are there in group G, so the order of the group is equals to 8. Here places a binary operation. So what is the formula to find the number of generators of the finite cyclic group? Pi of n. What is pi of n? Pi of n is a Euler-Student function. By using Euler's function, pi of n equal to what we write? Pi of 8. Here 8 can be written as 2 cube. So n value is 8, p1 value is 2. Substitute the values in the formula of Euler's function. 8 into 1 minus 1 by 2. Here 2 and 8 get cancelled. What is the value here? 4. That means 4 generators exist for the group G. So it is the most important problem. This problem mainly useful for CPGET entrance examinations. What is the formula to find the generators of the finite cyclic group? If GCD of element and n equals to 1, if GCD of the element and order of the group is equals to 1, then that element is a generator of the finite cyclic group. Now let's see here a raised to 1, that means 1. Here GCD of 1 comma 8 is equals to 1. So 1 is a generator of the finite cyclic group with G. Next, let us take the 2. GCD of 2 comma 8 is 2. So 2 is not a generator. Next, let us take the 3. GCD of 3 comma 8 is equals to 1. 4 comma 8 GCD is 4. So it is not a generator. Next, 5. 5 comma 8. GCD of 5 comma 8 is equals to 1. 6 comma 8. What is the GCD of 6 comma 8? So 6 is not a generator of the group G. Next, let us take the 7. 7 comma 8. 7 comma 8. GCD of 7 comma 8 equals to 1. Here, remember this formula. GCD of element of n equals to 1 except to identity element. Except to identity element. So what is the identity element? A raised to 8. So here we don't take the value of 8. Okay. So remember this formula. GCD of element and order of the group is equals to 1 except identity element. So here 1, 3, 5, 7 are the generators of the finite cyclic group G. Now let's see the example number 2. What is given? G equals to 1, 2, 3, 4, 5, 6 with respect to the multiplication modulo 7. Here how many elements are in group G? 6 elements. So the order of the group is equals to 6. Here what is the binary operation? Multiplication is a binary operation. So what is the formula to find the generators of the finite cyclic group? Order of an element equals to order of group. If order of an element equals to order of group except the identity element, then that element is the generator of the finite cyclic group. Here observe 1 is the identity element of group G with respect to the multiplication. So we don't take the value 1. Next let us take the 2. 2 తీసుకున్నాం అనుకోండి ఏమొస్తుంది? Order of 2 equals to 3. Order of 2 equals to 3. So it is not a generator. Next take the 3 here. Order of 3 equals to 6. Order of 3 equals to 6. So order of an element is equals to order of the group. Order of an element equals to order of the group. So 3 is a generator. In this group 5 is the inverse element of 3. In this group 5 is the inverse element of 3. If 3 is a generator, inverse element is also generator. Here 5 is also generator of the cyclic group G. మీరు మిగతా సాల్వ్ చేయొచ్చు. 4 and 6 చేస్తే మనకి order of the group is not equals to order of an element వస్తుంది. So 4 and 6 are not generators of the finite cyclic group. Here what are the generators? Only 3 and 5 are the generators of the finite cyclic group G. Okay. In next video we will discuss some more important problems and tricks of the group theory. Thank you.